So today we're going to talk about hardware and software, right? Um, most of you probably know a lot about this topic, but nevertheless, we have to cover this just to make sure, right? Folks who may not be so much familiar, or educated. Also, there may be some finer aspects of this topic that you may not know. So that's why we, just go through this chapter, okay? So as it relates to hardware and software, we're going to talk about, what are the main components of a computer, right? And as it relates to any type of information system or software, right? It can be categorized in many different ways. But one of the ways to look at it is if it is something that's built for what? A single user or a multi-user. So we'll talk about some examples later on. And as it relates to the multi-user computer system, that's where, some of these servers and other things that you have probably heard about, right? Web server, database server, you talk about application server, middleware, so many different flavors of servers are there. What you would typically see in a data center, right? Are not personal computers, but typically what? These servers which are meant for multi-user use, right? And as it relates to the data center itself, there are a lot of things that can be done, especially these days with global warming and other things, right? Making sure that anything we do is kind of done in a eco-friendly, environmentally conscious ways. So that's where the term green computing is important to know, right? So to understand what that means and what are the goals of green computing. And moving on to the actual software, that's pretty much kind of the big picture of the hardware, right? And you talk about software, we talk about, what are the main types of software out there, system software, you've got application software, right? And how do they differ, right? In their functionality and other aspects. And this terminology of sphere of influence, we talked about the software being for single user, multiple user. So sphere of influence has to talk about, application software in general, again, for personal use or group use or enterprise-wide use, right? And depending on that, there are certain things that are unique to each type of, software, right? More expand on operating system and middleware and things like that later on. Application software is something that anybody who's used a computer, right, at any point in life, and even nowadays with smartphone, that's the type of software that typically they may encounter, Not many people are interested in doing a lot with the system software, although we should know that system software is kind of the foundation on top of which, application software can operate, right? So that's the main difference. And and that's where, from an organizational standpoint, we're going to talk about how these application softwares are, supporting some of the personal use cases and group use, as well as what enterprise-wide use, and how they help meeting the business objectives of a company. And application software typically built using some type of a programming language, right? If you've done programming, you probably know so many different programming languages out there. Most popular ones, what? Anybody?
Python.
Python, yes. And if I were to put a number, it's not anywhere even more than 100, right? Python and .NET, Java, HTML, anything that you use to code is typically what's called a language, right? And as it relates to software, so many things that we can familiarize ourselves, right? In terms of what are the trends as it relates to software, right? And also, what are the issues trying to run all these different softwares within an organization, right? That we as management professionals need to know. Okay. Let's see, somebody. So hardware, pretty much, what can I say? Most of you use some type of computer hardware at some point. And what are the main functions it does? Helps provide input to your computer server, right? And input could be data, it could be, other type of things, right? And typically, but it's data. Processing is kind of that main activity that any computer performs, where it's taking data, transforming it into something more useful, and outputting it for the end user, right? And once it's done, computer typically, may store that information, some kind of a data storage. Chapter 3 talks more in detail about database and other things, right? But from the standpoint of this chapter, we're talking about data is stored somewhere, right? And output can be sometimes, without storing, it can just display on a computer screen, or can output the information to some kind of a paper-based output, right? What are the main components of a computer? Again, it's not a class in computer engineering where we go in depth, but at least we should know that at a basic level, a computer is made up of what? Some of these main components, CPU, right? What does a CPU stand for? Anybody?
Central Processing Unit.
Central Processing Unit, that's right. And then we got the main memory, and also the input-output devices that are providing information and receiving information, right, from the computer. And data bus is nothing but, think of it as a big data pipe that helps move data, right, between the CPU, memory, and input-output devices. Address bus is another thing. As you know, data is stored in memory in different address locations. So that's some way to kind of identify and read that information and update it in the main memory, right? So CPU, what are the functions that a central processing unit does? Just does all kinds of pretty much mathematical operation, logical operation, right? And it's the main control unit of a computer, right? You can have the best parts available, best components, but if the CPU is not functioning, that's pretty much, right? There's no use with the computer. It's like the human brain. And that's the computer, component that executes instructions, right? And provide something that's of value to the user, right? So memory is nothing but another main component of a computer that is providing that storage area, for the computer to hold data, for the programs, to process, right? And also it holds the information that's been processed by the programs, right? Nothing of any kind of instruction execution happens, just storing of data. It could be raw data, process information, right? In a computer, you can think of when you launch a program, what it does, just loads that program in the memory, right? That's how, as and when you're doing anything within that application, everything happens so fast, right? Input output devices, so many different kinds, starting with the mouse and, all kinds of pointer devices, and output meaning, your monitor, printer, fax machines, anything that can be used to what? Display processed information, right? And other terminology that you may already be familiar with as it relates to processor, right? That's the CPU, is the so-called clock speed. That's kind of a measure of how fast that processor is, right? How much of instructions it can handle in a given amount of time, right? Nowadays, CPU speeds are what? Measured in gigahertz. There used to be probably a time when it was all in kilohertz and then moved on to megahertz, now giga, right? If you ask me, maybe in 10, 15 years, we may even see CPUs that are, having speeds in the what? What is the next level after gigahertz? It's kilohertz, megahertz, gigahertz, what?
Terahertz, sir.
Terahertz, right? That's about 1,000 gigahertz. We may get there, right? So giga is already saying what? Billions of cycles. But when you say tera means we're talking about trillions, right? So most of the computers, even this is kind of a book that was printed, a few years back. But today we are already in that 10 gigahertz range if you go look up any of the websites, right? And those are the type of things that I expect you to do. And maybe, if you find something interesting, you can always share in the class, right? Hey, your slide talked about 1 to 4, but I went to Intel.com or AMD, and they're talking about 10, 15, 20, right? But the bottom line is more gigahertz means more clock speed, more expensive too, right? So as it relates to processing, there's different types of processing, right? You got the multi-processing, co-processor, multi-core, right? So most of the computers today you can call it like multi-processing. Why? Because they can execute, more than one instruction at the same time. So you can be playing a music, on your computer. You can be working on a Word document, right? You can be printing a document, right? All of this is happening, simultaneously. And think about if it did not, then you'd have to stop what you're doing only to print a document, right? Or you can't be listening to music as you're typing a Word document. So that's the advantage of multiprocessing, right? So co-processing is a different kind. So let's talk about the, type of processing where everything is sped up, right? Where it's executing specific types of instruction. While your main processor is working on some other activity, right? It's kind of a secondary processor is what you can call, right? Maybe for certain auxiliary functions, if you want to call it that. And multi-core is most of the processors today, they're not like single core. You at least have dual core, quad core means 4, and then, multiples of that, 6 or maybe 8. And that way you're able to kind of divide the processing into different subunits called cores, and thereby you're able to achieve, so-called more speed, right? Another type of computing, personal computing, enterprise computing. Then there's this so-called parallel computing, right? So some of the tasks that are performed, for example, think about weather analysis, right? If you're trying to analyze the weather of St. Louis for maybe, or forecast the weather for St. Louis for the next 1 week, that's one task, right? But it is so complex that if you were to just, depend on all of that complex calculation to be done on one processor, it may be taking longer, right? Maybe hours. But instead, if you have parallel computing, you can be executing that same task on multiple processors simultaneously, and then bring back the data, assemble it, and then, output that information. So that's how we achieve higher speeds, right? What is the point of weather prediction taking several days, right? That's not going to be of any use, right? That's what parallel computing. That's just an example. There's so many other complex analysis happening out there that takes several hours, right? Days. So massively parallel is, we're not just talking about a handful of processors, but what? Thousands of processors working, operating, right? In conjunction with each other and helping complete that processing much, much faster time frames, right? Especially in nuclear engineering and weather, again, climate prediction and all that, right? All this takes hours, right? And by using this, we're able to speed that up by factor of 10, maybe, right? And grid computing is something that very common these days. You probably heard about some of the things with DDoS. What is DDoS? Typically, that's why grid computing, is popular, right? Distributed denial of service, where you're using multiple computers from different parts of the world to attack a particular website, right? To just cause disruption, right? But all of these computers are working together to either solve a problem or cause problem, right? And today, nowadays, with cloud computing, it's even more easier, these type of things. So moving on to other components of a PC, main memory is where all of the data is stored, both data to be processed, also, data that has been processed, right? And so-called the working storage area for your programs and data. So within the RAM of your computer, it's not just the programs that are stored, also the data related to those programs are stored as well, right? The reason we need to have a main memory and not just the hard disk is because what? That's how your CPU is able to get the data rapidly. If that was always hitting the hard disk, then it would be taking a lot longer, right? So this is a memory that's sitting right next to your CPU. And the storage capacity typically, measured today, in gigahertz, right? Although back in the day, 30, 40 years back, it was kilobytes and then moved on to megabytes. Now it's gigabytes. Hardly you can find a computer these days that has less than maybe 4 gigabytes of data, right? Or memory. But the point is, the bigger the memory, the more expensive, right? And that's just an example of how you express the storage regarding your main memory, or could be, secondary memory, all the way starting from kilobytes. Byte is nothing but what? 8 bits. And kilobyte is 1,000 byte. Mega is, 1,000 kilobytes. Everything in the, order of thousands, right? And most of the PCs today, they almost have a half a terabyte, 1 terabyte of hard disk, right? And as I predicted, maybe there will be a time where we have several, like terabyte or terahertz of CPU. We may even have a terabyte of, main memory. It's just a matter of time. And the higher order petabyte, exa, all of these things, good to know. Just because, we are almost at a point where if you were to say how much is the world information, how much of bytes, we are already at the Yoda byte, right? And moving on to the types of memory, right? This is again something that you already know. We have RAM, and also what is the other type of memory? ROM. RAM is random access memory, which is nothing but what? Why is it called random? Because it's very temporary and, volatile. So what does it mean by temporary volatile? Means that, it can be refreshed, very easily. Also, anytime you shut down the computer, everything that's in the RAM is gone, right? So different types of RAM all the way, evolution of RAM. It started with maybe static RAM and then became more of dynamic, right? And then the so-called double data, RAID dynamic RAM. So the evolution since the last maybe 30 years, right? 30, 35. And so we've got DDR2, DDR3, DDR4. And in addition to, more speed and more memory, right? Nowadays, what is more important is the energy, right? Usage. So that's where some of the focus is. Less energy means your battery lasts long, right? So ROM is nothing but random read-only memory, right? RAM is random access, ROM is read-only. It's the complete opposite. It is non-volatile. Means once I shut off the computer, right? I still will have the data. And that's where the data that your computer needs to start up, that's where it's stored, right? And it's permanently burnt at the time of manufacturing that PC, right? On top of this ROM, we have other type of storage, right? Secondary storage. Your so-called hard disk. It used to be where, hard disk was only a few hundred megahertz. And you know what? Today, you're almost at terabytes, several terabytes, right? And that's where any kind of large amount of data is typically stored, right? For later use. And that is also permanent, right? Even if you shut down the computer, the data stored is permanent. Won't get wiped out like in RAM, right? So some of the advantages of this secondary memory is what? We talked about non-volatility, greater capacity, where your RAM is usually in the 8, 16 gigabyte, right? You can have a hard disk that can be what? Several hundred gigabytes, terabytes, right? And the greater economy of scale is what? If you say for 1 gig of RAM, it costs maybe about $15. Maybe for, 10 gig of RAM, it could be about $200, right? But in the case of hard disk secondary, it's not going to be, that much, right? If 1 gig is, of RAM is going to cost you $25. In the case of hard disk, it's going to only cost you maybe, 50 cents, right? That way, even if you have a terabyte of hard disk, all you're paying is maybe, $500. Even that is also expensive these days. You can even get it for lower, right? That's the economy. That's why people would prefer maybe in some cases, if you're not using your computer other than for browsing, maybe, you know what? The amount of money I spend for RAM, I might as well spend for my hard disk where I can download, a lot of videos and audios and things like that, right? And even the secondary storage has evolved, like we saw with the RAM, right? DD or RAM, DDR, SD-RAM, R4 and all. With the secondary, it has evolved from what? Back in the day, it was all magnetic disk, and that changed to optical or maybe faster speed. And nowadays, everything is what? Solid state, which means there's no moving parts. That's why most of the laptops you get these days, the battery is lasting longer because, hey, secondary storage, you're accessing data. There's not much energy required, right? And it's much faster too, and more durable too. So if you drop it, your laptop, unless the cover breaks and things like that, your hard disk probably may not suffer, much of damage. But if it was a magnetic or optical, then, there's a good chance it may get damaged beyond use, right? Other types of storage just to know about is magnetic tape, which has kind of been used for a long time. Usually used in what companies as what? Used as a backup. Backing up the data for some kind of a, future use, just in case there is some kind of a disaster or something, we can always go back to those tapes, right? And I think other type of usage, you can think about starting with what? Your compact disc back in 1990s, very popular, right? Compact disc. Then came, DVD, which was compact disc was few hundred megabytes capacity. Then came DVD, which was in the gigabytes range. And the popular one was what? The Blu-ray. It had about 5 gigabyte capacity. That's how you could record the movies, right? Another type of more advanced is to say called DNA storage. All kinds of things are being, invented. Every year we find something new introduced by these innovative companies, right? The most popular one, obviously, in terms of secondary is what? Solid state. And the reason it's solid state because no moving parts, right? You can think of it as a bigger version of your USB drive, right? USB's capacity is usually, 32, 64. But in this case, it could be terabytes. Advantage is less power, more speed, and less fragile than your old version of hard disk, right? And probably you didn't realize, even the flash drives that you are carrying is one form of what? Solid state, right? And then moving to the next level is what? You talk about terabytes, now we talk about petabytes. which is what you need for what? Enterprise storage, right? Where you're trying to store information of hundreds of employees, right? All of the documents they're producing and all that stuff. So that's where one of the popular terms to remember is what? Storage area network. And it used to be popular, I think, in the 1990s, 2000s, before cloud computing maybe came into picture. Even now we have, no doubt, right? And what does a storage area network do? Pretty much what? Provides a lot of different functions, right? And it's kind of a high-speed, special purpose, network, right? Where you can integrate all different types of data storage into this one single storage system, right? Which your computers and servers can connect to. So they don't really need to bother about whether it's from a CD-ROM or, backup tape or, whatever the media, but I'm just accessing the file as though, it is on a solid state, right? Other capabilities that SAN, storage area networks, provide is what? Disk mirroring, where it means you can just replicate that information very, very quickly. Backing up is having backup or multiple versions of data, right? Just in case there was crash of the, main storage, you can always go back to the backup to restore, right? Restoring is another function. If you're able to back up, you need to also be able to what? Restore. Archiving is moving some of the older information into a more cold storage, right? That's not actively used. And also you can share data among, different devices. So that's the power of what? Storage area network. That's a kind of a graphic that describes the storage area network. And that's the main system. And all the computers are accessing it through the PC, where you'll have just kind of a network folder, right? That's mounted on your computer. And then you can create your own files within that and store it so that even if your PC were to crash, all of
Hi,
that
Professor.
information is stored, right?
Yeah, sorry to interrupt, Professor. One of my friend was unable to join the meeting.
Already done.
He was already joined, but due to network issues, he was disconnected.
Oh, okay.
Yeah. Shivkeshav Reddy.
Yeah. So behind the scene, it can, connect to storage of different types. It can be a tape, it can be a disk, it can be some other type of hard drive, right? But the computers really don't know. For them, it's all about files, right? Stored at different, network subfolders. So that's the storage area network, but now with cloud, what can we say, right? Everything is more of a service. So instead of owning all of that expensive hardware and software, all we are saying is you can go to the cloud, you can procure maybe, petabytes of data. And all you do is pay a monthly fee, right? Because you don't own the server, you're just renting, right? The storage. And this is something that both individuals and organizations can do, So the main way to access that information is through what? Your internet. All you need is internet connection and some kind of a login, and you can access, right? It's very popular these days. So some of the popular storage service providers are Amazon, Microsoft, Dropbox. One of Amazon's most popular, S3, right? Simple storage service. It's one of the most cheapest and most popular, right? Allows individuals and, you know, organizations to upload any type of file, be it video, audio, images, right? And there is no limit as to the amount of storage, right? So if you're interested in something like this, you can try signing up for Amazon's services and then try it out yourself, right? And check it out, how much it costs for a month, you know? Even for something like a terabyte, maybe it'll cost you a few dollars, right? Nothing more. So moving on, you know, from storage to all this input-output devices, you know, this is all something that most of you familiar with. Input device, as the name says, is how user, right, is providing data or some kind of an instruction to the computer, right, to allow the computer to do, you know, the intended processing and output the result, right? Most of the way today, people input data is what? Using some kind of a form or some kind of a, you know, interface, like a screen, right? That's how they enter data. And sometimes you can use a mouse, you know. And what they're saying is most of the companies today provide access to their employees, you know, for a PC, comes with some software and things like that. But the key thing is the organizations should keep in mind what are the employees' job functions, right? If I'm a graphic company, maybe I need to invest more on high-end, you know, input devices like more fancy mouse and, you know, more expensive displays and things like that. But if I'm just doing some regular, you know, office functions, then maybe I can just get by with some, you know, general mouse and keyboards and things like that. So you have to keep that in mind as you're procuring all of these input-output devices. Examples, you can read all of this, but I'll just pick a few. We talked about keyboard, mouse, and nowadays, most of us is what? SRT, speech recognition technology, right? You don't need to have to type or click a mouse. Everything is what? Driven by human speech, language. Like, what are some of the popular devices that are based on speech recognition technology? Anybody? You can maybe type it in chat if you don't want to unmute yourself, right? Could be some kind of a motion sensing device like this popular Ring, you know, bells, and, you know, could be
CVI.
video, what is it called? Security cameras, things like that, right? Even scanners are input devices, optical readers. And what you see in a ATM machine is MICR, right? Magnetic ink character recognition. That's how when you deposit a check, the ATM machine is able to detect the amounts and things like that. Siri, that's an example. Alexa, right? Google Home, all those things. So in a given check, typically, you know, some of the information is magnetic. That's how those machines are able to read, right? Information. Other type of input devices, you talk about so many things, right? But the most popular one is a barcode scanner, which is something that you would see in most of the stores. Touch screen is an input device too. All of the things we do on our smartphones, pretty much, as we are launching apps and things like that, that's kind of an input device. RFID, radio frequency identification. These are the things that a lot of companies are using to speed up their business operations, right? That's an example of a RFID tag that you may have seen in some of the stores and things like that, right? So different types of display, right? Input, we saw, now we're talking about output, right? So output wise, what can I say? Now, the evolution of the monitors, light, all the way from the CRT, cathode ray tubes, to it used to be plasma, and now it's all, and then came LCD, LED, OLED. A lot of these companies like Sony and Samsung are innovating a lot on the display just to make it more crisp and clear and less thin, right? The monitors, less energy consuming. A lot of innovation continues to still happen. And other types of output is printer, plotter, right? And one of the most popular output device are, that came up in the last maybe 10 years is what? 3D printer, right? Where printing used to be 2D, but with 3D, you're able to print pretty much parts, right? Using these so-called things called 3D printers. And it's using some kind of plastic filament, right? Or some powder to build these or create these parts in using some kind of layers, right? And there's no limitation on how complicated these parts can get. Very popularly used by aerospace and auto manufacturing firms. And, it could be for prototyping, or in some cases, especially the space industry, right? Where they are producing parts, not necessarily in the millions, right? They only need a few of the specialized parts. So to speed up the manufacturing and reduce costs, they're using all kinds of 3D printers, right? If you go do some research, you'll see that there are 2 or 3 companies that are top companies in 3D printing, and one of those companies are producing 3D printers for what? Space companies, to produce those huge parts, right? They're probably as big of a size as, half the size of a room, right? So that's 3D printer example of a 3D printer is what you see here. But if you need to see a live 3D printer, then, and you haven't seen one, right? You can go to some of the libraries. They have those 3D printers, right? And they will allow you sometimes to, print part, right? And sometimes free of cost. Or if you go to the Science Center, St. Louis Science Center, right? They've got a room that has a lot of these 3D printing machines, right? So that's output for you. And let's see, moving on. Any questions on anything we covered so far? Input, outputs? I know it's kind of a big chapter, so I just want to make sure that I take some pauses and answer any questions you might have. So types of general purpose computers. We talked about, computers for what? Single use, multiple use, right? Most of the things that you use is probably what? Single use computer, right? And the most of the ones you see in a data center or computer lab, maybe, all multi-use, right? And nowadays, the most popular one is what's called mobile computing, right? Because easy to carry and small, right? So with these popular smartphones, you're able to do so many things, right? On top of placing calls or sending text messages, doing your video chat, you're able to download, install app, and perform pretty much a lot of functions, right? Be it playing video games or working on documents, printing, or using it as a map, right? For navigation, playing music. What can I say? There are about 2+ million of these apps in each of those app stores, right? Google and Apple stores. So in addition to the smartphones, what do we have? We have the popular, laptops and notebooks, but what's the difference, right? So laptops are for mobile use, right? But they have a lot more processing, storage ability, right? And notebook and ultrabooks are meant for more of light use, right? And the advantage is because they are very light. People like to carry them anywhere they go. But again, the types of things you can do on a notebook, ultrabook is very limited, right? Doesn't have much storage or CPU. And tablets, obviously, even more popular these days, Apple and Samsung. The reason they're popular is why? Very, very lightweight. And the reason is because they're thin and they're also don't necessarily have a keyboard, right? When you eliminate a lot of these peripheral things, then everything becomes lighter and easier to carry, right? So you can look at an example of a tablet, it's all things that you know. Other things to remember when it comes to computing is things like thin client, desktop, workstation. What's the difference, right? Thin client, nothing but what? It just has a look and feel of a PC, right? But doesn't have much of CPU or storage, because everything it does is by connecting to another mother computer where all of that processing and storing is happening. All this is doing is just kind of a more fancy monitor, right? Everything that you do is done in a central server, right? Citrix is a company that became very popular in that space. Desktop, nothing but regular computers you find at home that can do a lot of the, functions that you typically do on a computer, right? Highly versatile. So you can install programs and do all kinds of things, right? So workstation is typically, well, you would give a desktop computer to person who's maybe working in a accounting department, finance, and things like that. But workstation is something that's a more powerful personal computer, right? It generally comes with better, more powerful CPU, more memory, right? Because that's what you need for, things like developing applications where you install a lot of these IDE and other types of software, or you may be into gaming or graphic design and things like that, right? So they're more expensive, and the reason is because they have that additional CPU and memory and things like that for heavy duty use, right? And next up is what? The next level of computing, right? From personal to what? Enterprise. So here we're talking about servers, right? That can not only meet the needs of one person, but they can, perform tasks of many people, right? Serving web pages, it could be printing a document or doing any kind of heavy analytics type of operation, right? Can do many things and can support the requests of multiple people, right? So other terminology to remember in that as it relates to server scalability, right? A lot of the servers, when you purchase, they come with some CPU, memory and all of that. But then as more and more people start to use it, things tend to slow down, right? So at that time, you have a choice. How do I, support more users? Maybe you can scale the memory, right? Add more additional memory, right? Some cases you may be able to add additional processor, right? Storage, things like that. But there is a limitation, right, on how much you can scale. And the reason you do that is to what? Handle more users, more transactions, right? That's scalability. And that's why cloud is so popular, is there's no limit to how much you can scale. There's one thing called vertical scaling where you can add some additional CPU, memory, and all that. The other thing is horizontal. There's no limit to how much you can expand, right? Mainframe used to be popular 40 years back, right? Used to be a mother computer that handled the needs of hundreds of concurrent users, right? IBM was one of the most popular company in that space, IBM. And, there used to be a company called DCX and all those, right? AS400, ES9000, Hewlett Packard used to have their own mainframes, right? And the main thing is you had this mother computer that did all of the processing and storage. But end users used to have some kind of a dummy terminal, right? And a keyboard for entering information. And the most powerful of all the computing or computers invented by humans, right, is what? Supercomputer. These are the ones that you typically find in university labs or labs of big universities, in big scientific research institutes, right? Governmental organizations, because these are computers that are so expensive and they are so fast that you need some real valid use cases for purchasing and running these things, right? Requires a lot of people to operate and consumes a lot of power and space and all those things, right? So it's called supercomputer. United States used to be the leader in this. I thought I read somewhere that now China has the world's fastest supercomputer, but that keeps changing. Every so often we find out, some one countries kind of taken over another country in terms of, the fastest supercomputer. So that said, moving on to what? Data centers, green computing. So data center, nothing but what? A huge building that hosts, hundreds and hundreds of these servers, right? And, some of the servers can be doing the job of processing, some can be doing the job of storing, many different functions, right? And the reason why we have data centers is what? That's how organizations can what? Meet their computing needs in a more efficient, environmentally friendly manner, right? Versus having every department have its own servers, right? You have a big room where you have all of the servers required by all the departments, right? Everything accessed through some kind of a fast network, right? So server farm, nothing but a large, building, right? That hosts hundreds of these servers. So if you go to Google website, I think there is a link at the bottom that talks about, how Google search works. When you click that, I think it may take you to another page that talks about Google's cloud data centers, right? And you will be amazed how large those data centers are, how people, they don't just walk, they have all these, Segway type of scooters that they use to kind of move from one place to another, because that's how large those buildings are. The key thing with these server farm is what? They are climatic controlled and only accessible to what? Authorized personnel, right? Not anybody can get into those buildings, because those are the people that end up managing and maintaining those servers, right? As it relates to server, another popular terminology to know is what? Virtual, right? So as far as servers are concerned, it's more of a physical thing that you can, see, touch, and all of that, right? But then came maybe 15 years back, this concept of, I would say even longer, 20 some years, concept of virtual servers, where you can take a physical server and logically divide it into what? Multiple different servers, each running its own operating system, application, and things like that, right? It helps kind of utilize the CPU memory. Usually every server, if you look at it, the CPU is only utilized, 15% of the times, right? Rest of the time is sitting idle. So what do you do with that unused capacity? So that's where the concept of this hypervisor software came in. So install that on a server, and then you can use that to what? Create these logical servers. And each of those, called virtual, can have its own different operating system application, right? By doing that, you're able to leverage, most of the CPU and memory, right? And that's become very popular last, 15 some years, right? Especially with cloud computing. So you can generate a virtual server in a matter of what? Minutes, not seconds, right? And that's how companies are able to save a lot in terms of the data center costs, right? They don't need to have an individual server for every different application and things like that, right? So data centers, again, data farm, you got the, server farm, and then data center is pretty much very similar, right? Climatically controlled building, and it pretty much hosts a lot of these servers, hardwares, right? And it serves the information needs of an entire organization, right? And why are companies moving more and more to these data centers? Because what? Especially cloud. Because of the demand for additional computing. Everybody needs more storage. Everybody needs faster servers and things like that, right? As demand grows, it's practically not possible to keep purchasing new servers every so often, right? Also, the storage demands are increasing too. But every employee used to be able to get by with maybe 100 megabytes storage. Nowadays, that's laughable, right? Even your smartphone has what? 128 to 56 gigabytes. So when you have a company with hundreds and thousands of employees, that can add up, right? And with SAN and other things, you are limited, right? But with cloud, you can add additional storage very quickly, right? So those are the things to know about your data center. So some of the things to consider, right, while building a data center, what are those? Make sure that, the energy consumed for operating those centers are, not too much, right? And how can you achieve it? By following some of the, basic things like designing your data center in kind of a modular fashion, right? Locating those centers in more milder climate. Why do we have to have mild? Because there's so much of servers that generate so much of heat, right? So if you're in a place where there's, mild weather, then you can use some of that climate, cool weather for your advantage, right? Rather than spending ton of money on cooling those data centers, right? Because if you don't cool it to that optimal temperature, about 60 to 70 degrees, right? Those servers can run really hot. And that can end up, causing issues, right? And also make sure you locate the data centers place with less land costs. Because data centers are large, they require a lot of land, and land is expensive means it can add, right? On top of that, if you need to expand, okay, if the land costs less, then it's easier to do that, right? Also locating those data centers in a place with less of, chances of natural disaster like hurricane, earthquake, tornadoes, and things like that, right? Also away from any kind of places where there's lots of things like war and other, issues. So those are things, right? Green computing wise, what can I say? Making sure that your data center operation is done in an environmentally responsible way, right from the design, manufacture operation, including the disposal. Design means what? The servers that I purchase are manufactured and produced in a very environmentally, friendly way, right? All the materials used to create those parts, things like that, right? And also operating of those data center needs to be also in a environmentally friendly way, right? Not using too much of energy and including the disposal. So once those servers reach their end of life, you just don't want to just throw them into some kind of a landfill, right? To have a plan in place to safely, securely dispose those machines, so that they don't end up harming the environment, right? Because a lot of these servers are built of, some hazardous materials that if you just throw, into a landfill, that can end up affecting the groundwater and things like that, right? And also the goal of green computing is what? To lower the power costs, because power is one of the big costs for these data centers. If I can lower my power cost, I can save a lot of money. Safe disposal, we talked about that, right? You can either safely dispose or recycle, right? The equipment, be it because a lot of these servers have a lot of silver and gold and things like that, right? By recycling, you're able to reclaim some of those precious metals at the same time. Also prevent a lot of those hazardous materials from going into the landfill, right? Like cadmium and all those things, right? Almost at halfway point, we can maybe take a break in a few minutes here, right? So there is the lot of organizations available or, that have been created to come up with standards for green computing, right? So one of the popular ones is what this EPEAT, right? Electronic Product Environmental Assessment Tool. So it just helps evaluate, any data center, how environmentally friendly they are. And based on that, they give all of these, ratings, right? Bronze, silver, gold. So typically you have these 51 environment criteria. And to get even a bronze, you have to meet at least 23, right? But if you want silver, then you have to at least meet what? 25, right? 26. You have to be gold, then you're talking about at least, 40, right? Of those criterias to meet to be certified a gold star data center, right? That's pretty much on hardware. Any questions, anybody? These guys have been waiting for a long. So any questions on hardware? Okay. So let's take break and come back 7 o'clock. And we're going to talk about software. Okay. So see you back in about 15 minutes. Okay, welcome back. So last section, we covered all the hardware related topics. Now we will move on to what? Software, right? Which is what most people are typically dealing with when it comes to computers, right? So as far as software is concerned, pretty much different kinds of software out there. You know, starting with system software, which is nothing but the foundational software, right? Things like your operating systems. Utilities are things like, that comes with a computer. For better memory management, right? Lots of functions to help the computer, right, operate more efficiently, right? And middleware type of programs are something that help, as they say, right, manage a lot of the activities of the hardware, right, and other programs to make it again run more efficiently. So some of the popular operating systems, as you probably guessed, starting with Windows, used to be Unix, now it's all Linux. That's for server and PC. Now Ubuntu is another one. And Mac OS, obviously, if you're a Mac user. Then we have for the smartphones, right? We got iOS, Android. There used to be other operating system, but those could not compete with the two popular, right? Operating system, Android and iOS. And then comes the most useful type of software, which is the application. That's what helps end users like you and me, carry out our day-to-day, activities, right? Could be personal, it could be professional activity, right? It's where we can use it to, solve a lot of our day-to-day problems. So that's the main categorization of software, right? System and application. So another way to look at software, is who is it for, right? Especially could be operating system or could be, application. It's the sphere of influence, right? What is the problem? Opportunity it's solving, whether it's for the individual or for the organization, right? So if it's for the individual, then it's called what? Personal sphere of influence, right? It just serves the needs of one user, right? And there are millions of apps that do that today. And also we have in most of the companies and even individuals at homes too, right? The so-called personal productivity software like Microsoft Office Suite software and other things that help people, do a lot of their activities like document production, creation, presentation, a lot of things, right? And moving on from personal is the next sphere of influence that helps two or more people work together to achieve a common goal. It could be working on a document, it could be working on some kind of it could be a video, audio file, right? Anything. So it's not just for an individual, but built for more than two people. So on top of that, we have, which is the highest level, the enterprise sphere of influence, right? And that's something, a software that you build for helping the operation of an entire company. So these type of software typically, cannot be installed on a PC, but usually on some type of a server, right? So that's an example of, system software for personal, work group, and enterprise sphere of influence. And the same thing with application software, right? And here, some of the things that you probably don't know is the enterprise, right? The case of enterprise at the operating system, we have the server mainframe operating system, Windows server and things like that. Also, application-wise, you have order management system, accounting system, and general ledger, payroll, all those things, right? But as you may be popular with the personal, the work group sphere of influence. The system software, as I said, is kind of the foundational software, for any computer, right? Pretty much controls all of the operation, right? Computer, including the hardware, right? And it is required for the operating system or application programs to run, right? So within the system software, you have several kinds: the operating system, utility, middleware, right? Operating system, I gave you examples. Utility-wise, we talked about it could be a printer plugin, right? It could be some kind of a scanning software. It could be, a disk fragmenting tool, or it could be something for security, right? All those things are utility programs. Middleware help your server connect with other servers to help with some of the integration and other needs, right? Operating system, we may think of it as one single program, but it's actually made up of a lot of, smaller programs that help you to do a lot of, things with your computer, right? Let's see. So what are the things that are built within the operating system? That's kind of the graphic representing the different roles, right? You've got the hardware and the hardware drivers, the kernel, application program interface, that's the GUI, right? Sometimes it's the non-GUI portion and then the GUI portion. That's the kind of the layered way, right? And the role of the operating system was to act as that interface between the application software, right, and the hardware, right? So the hardware is nothing without the operating system. So within the operating system, there are so many different components, starting with what? The kernel is kind of the heart of that operating system. It controls a lot of the critical processes of the operating system, right? So you may be thinking, while I'm in my room, I'm doing nothing, but I see some kind of a fan, sound on my machine, or what is it doing, right? Sometimes even though you're not using it at that time, it may be doing a lot of other functions, right? So that's that component that's tying all of this operating system components together, right? Functions performed by OS. Let's talk about input-output management, right? That's how your mouse is able to function, right? When you move it, how do you see that pointer move on the screen? Because of your operating system. Memory management is a big thing. Being able to manage multiple tasks, right? Helping them run sometimes concurrently or one after another. Networking capability is a big thing, right? There was a time when you only had one computer and all you could do is just run some software for some of the individual needs, right? But then came all of these networks that allow you to connect one computer to the other, right? So all of that networking modules are also built within that operating system. And managing files, controlling access to system resources means what? Providing you access to memory and CPU and so many different things like hard disk, other things, right? And if especially you want to become a system administrator, then this is what you will focus more on, right? Ensuring that the OS is running optimally and doing all the things to make it do its function more effectively, right? Other hardware functions, on top of input-output management is storage, right? Managing the storage and retrieving data, displaying, all of that is what? Part of the hardware. So what's that main thing within a computer that allows you to display information on a printer, right? It's what's called a graphics card, right? That's what you need in every computer for rendering all the information on the screen, right? And let's see. And GUI is the very popular term, that you all should know, I think. Graphical user interface, nothing but what? All of the screens that we have within our programs or applications that help us perform part of our functions, right? Activities using those, operating system or application software. That's an example of a Windows, DOS prompt. Does anybody know how to launch this DOS prompt? Have you ever done that? So just so we're talking, right? How do you launch a DOS prompt? Let's go here, do a CMD, right? Command prompt. It used to be all command driven back in the day, right? CMD, if I want to list folders and files in my directory, do a dir, right? I want to change my directory, right? I have to go to what? Documents, right? That'll change me, right? So a lot of things you can do with this command prompt, which is what a lot of people like, right? And if I were to do find the information about my IP, right, of my computer. That's what I do, right? Any kind of network activity on my computer, right? That's statistics. Tells me all of the ports I'm connected to and all kinds of things happening, right? So these are the things that you can do on your own, cost nothing, right? Moving on. And that's kind of the old school way of doing, right? Going to a command prompt and typing the commands. But most people may not know that. That's why they go to the Windows Explorer and go to the different folders and open documents, right? And what do operating system provide, at least in some cases, hardware independence, right? So hardware independence means what? Same operating system can be run on a Hewlett-Packard machine or on a Dell computer, or it could be, any manufacturer, right? So that is one thing. And also, especially with Linux, that's very popular, right? It can be installed on a Windows machine. It can be installed maybe on a Mac machine, right? But as you know, you cannot install a Windows software on a Mac machine, and likewise, the other way around. On the other hand, Ubuntu software is hardware independent. It can run on any machine, right? Although you may have to install the Mac OS version of that hardware or operating system. Memory management, very important, right? For example, again, if you want to know how much of memory your computer is consuming, anybody done that? What do? You go to a task manager, right? Again, because it's ITM 5000, I'm taking the time, right? Task manager, go there. You will see how much of memory is being used in this PC, right? Some reason we got 28 of this Google Chrome, right? It's taken up almost one of, I think, a fourth of my PCs, right? Same thing with CPU. And on top of that, if you're interested in some of the other statistics, right, it's got a 3.3 gigahertz CPU, and there are 260 processes running, right? So these are cool things to learn, right, on your own. So virtual memory, again, is something that your hard disk can be used by the CPU as some kind of an extension of a RAM, right? Your RAM may be only 4 gigahertz, but your computer needs more. If it's running out of capacity, then it can use your portion of your hard disk as a RAM. But in that case, it's going to do what's called a lot of paging, going back and forth, fetching that data, right? Which is probably not a good thing, can slow things down. As far as processing, we talked about, multi-processing, co-processing, and all of that, right? So all of these things are done because, typically a user does a lot of things, with their computer. So they want to have some kind of immediate response. So as I move the mouse, if it takes a few seconds to move, then it's not a good experience, right? It can be frustrating. That's why you have all this multi-threading, multi-processing, where I could be running multiple things, but I need to have this near real-time, response from the computer, right? Talked about that as part of our hardware. Networking is very essential, and it comes with every operating system, right? Because I cannot imagine of any operating system that doesn't have any kind of networking capability, right? That's how you're able to connect your computer to the internet, be able to access websites and share, data, receive data, things like that, right? And security is a big thing these days. It also comes with a lot of advanced security capability to ensure that, we're not allowing hackers easy access to our PCs or servers, right? So it used to be where security was kind of low in the priority, but now it's all, pretty much there, so that it's not easy to hack into even a Microsoft Windows machine, right? Comes with some kind of a default login, and you can create multiple login accounts, for many users, and they'll have the experience of as though that machine is meant for them, right? And you can track things like, who's using, what within the system, right? How long they've used. Also detect any kind of attempted security breach. So you have softwares, including your antivirus software that tells you a lot of these things, right? File management, again, has to do with what? So if you have files in your secondary storage, which is obviously where you keep all the files, or else you're going to lose them, right? You're able to access them as and when needed, and also prevent any kind of unauthorized access, right? so I can protect my files using some kind of a secure password, right? So that even other people access my machine, they will not be able to access some of the confidential information. So different types of operating system for each of the sphere of influence. And as I said, these are the things you need to spend time learning, right? That's how your Windows operating system looks these days. So back in the days with the classic Windows, it used to be all, not tiles, right? All like the typical menu-driven, interface. But then Microsoft moved away from that to this whole tile-based. People didn't like it initially, but then I think the world got used to it, right? And Apple has its own version of operating system, Mac OS. There's usually a version coming out every few years, right? I'm not a Mac user, so I don't know much, but they tend to name their operating system, differently, right? Rather than numbers, they used to call it by a certain name, right? Leopard and all of that stuff, right? Personal computing wise, we got Linux. It's a very popular personal computing as well as enterprise computing software. Why is it popular? Because it is open source, means free. Even you can today go to Linux, download, right? Software for free. But you need to know a lot about how to run that operating system, right? Think about a company. They cannot run their operating system on a unlicensed, unsupported, right? So if you need to have some kind of a supported version of this Linux, then you go for Red Hat or, SUSE Linux, right? The source code is available, but the support is not there for the open source. So you need to go for so-called commercial version of these software, right? That's how a open source user interface looks like. Very basic, but it's really lightweight operating system, okay? And then Google came up with its own operating system for Chrome, books, and that's the so-called Chrome OS that was based on maybe some version of Linux, right? And that was designed to run on some kind of inexpensive computers. That's why when you buy a Chromebook, you get it for under $200, right? Because operating system is free and doesn't have fancy CPU, memory, things like that, only for browsing, right? And for work group operating system, you need much more advanced version of the operating system because it needs to manage the needs of multiple users. Unix was one of the popular systems, of the 1970s. And then gradually was replaced by Linux, right? Let's see. As far as Unix is concerned, so actually they're saying Mac OS is kind of based on Unix too, right? It's kind of a more advanced, more user-friendly version of Linux, right? A lot of the popular websites are hosted on servers that are used to be based on Unix, right? But now mostly it's all based on Linux, right? And enterprise computing wise, these are the operating system that supports the needs of the entire enterprise, right? Usually you have IBM, Hewlett Packard have their own version of these operating system, right? I have, in fact, when I started out, worked with some of those popular mainframe operating system, like you probably never heard MPEIX, from Hewlett Packard. IBM used to have AS400, right? All those things, right? But nowadays you don't find those. And Google and Apple came up their own OS for what? Smartphones, right? What can I say? You know probably more than me. And then for cars and other type of devices, they come up with what's called embedded systems, right? Anything like a car, which modern days, you can have these fancy dashboards where you can do a lot of things like play music, connect to Bluetooth and everything, right? You have to think that it has to have some kind of a, operating system. Without that, it's not possible to do all of the things, right? So Windows and other companies produce a version of operating system for these type of devices like ATMs and Sony V is based on some kind of a popular or proprietary Linux-based system, right? Everything needs to have that foundation layer, operating system. On top of that, you have your software, which could be games or any kind of other type of software like Windows Suite and things like that. Utility programs, if you open up your computer and go to one of these folders, right, you'll see lots of these DLL and other type of files, which are what? Utility programs that manage a lot of the internal functioning of your operating system, right? Helps run your operating system efficiently. Also, troubleshoot too if there's a problem, right? These are the programs that help solve some of the problems, right? And middleware or softwares that help connect multiple systems so that you can easily exchange data. Because data in each system is in a different format, right? One system may not understand the data of another system, but with these middleware, you're able to convert the data to a format that each of the system understands, right? And that's where the whole service-oriented architecture came in, where I don't care if that other system is based on Linux, whatever, but we have this common interface through which we can exchange data, right? As long as both systems are familiar with that language, then it's easy to exchange that information. And then nowadays, you probably heard about microservices-based architecture, REST APIs, and things like that, right? It used to be SOAP, then it's nowadays what? REST, right? Moving on from operating system to what? Application programs. I mean, these are all things that you use from a day-to-day, standpoint. All it does is what? Help you do your job functions. Think about an enterprise, right? HR department. They may be using these office productivity tools like Microsoft Windows and Excel and things that every other department use. But on top of that, HR department may use some kind of a HR specific software, right, to do their day-to-day job functions. Same thing with the accounting department, finance department, marketing, sales department, right? Everybody has their own individual softwares they use to manage their day-to-day functions, right? So that's the difference between an application software and a system software, right? Does only specific functions, right? Let's see. And a lot of the companies have a choice, right? Whether to purchase off-the-shelf software for their department to perform their day-to-day functions, or they can what? Develop in-house software, which requires extensive programming skills and a big department. Need a break for it. Okay. Okay, go ahead. No problem. So, and there are probably literally thousands of software, right? I can tell you application software wise, you have literally thousands. Operating system wise, you probably have in the hundreds, right? So the difference between proprietary and off the shelf. Proprietary is what? Company owned developed software, you know. Off the shelf is some kind of a commercial software developed by a vendor like Microsoft, Oracle, SAP, a lot of companies, right? Salesforce. So there's lots of advantage, disadvantage, right? With each approach. And again, this is where, you know, after today's class, you should go and kind of read up on some of the advantages of developing proprietary software versus purchasing, right? Off the shelf. If I sit here and read for you, it'll be too boring, right? So take the time and read up that information, right? All I can say is with proprietary software, the advantage is you can build any type of, you know, company-specific functionality with your own IT team. There's no limitation, right? But the disadvantage is what takes time, takes a lot of resources, right? On the other hand, with off-the-shelf, the advantage is what? You don't need a large team to build the software, support it. You can implement those softwares very quickly. The quality is something that's guaranteed depending on the vendor. But as far as disadvantage is concerned, what? The license cost is high. And you may not have some of the company's specific requirements, features built into that software, right? And if you need to build it, you need to customize it, which may require time and, you know, resources, right? Moving on from that, nowadays with cloud, everything is a service. Anything you can think about, you could say as a service, software as a service, very popular version of cloud service, right? You have infrastructure as a service, software as a service, platform as a service, database as a service. Anything you can think about as a service if it's in the cloud, right? Where you don't need to essentially purchase the software, you can just rent it, subscribe to it, right? You're paying a monthly fee, right? And a lot of vendors in that space, Oracle, SAP, Salesforce, Google, you know, hundreds and hundreds of softwares that are available as a service. Other types of software application wise, you know, I've mentioned, you know, personal computing, word processing, spreadsheet analysis, even database software too, you know, they produce for individual use, you know. If you're interested in learning how to build a .NET or Java application, you can always download personal version of a Microsoft SQL database, right? Maybe Oracle might have too. Because every application has to have some way to store, manipulate, and what retrieve data, right? So if you're interested in some kind of graphic design and things like that, you need to have different type of software, right? For example, Adobe is very popular. Then you have CorelDRAW and other companies producing software for what? Graphic design. Another thing to know is software suite. What's the difference between regular software? Software suite is what? Just comes with a collection of these software, you know, where it's all bundled together, right? Microsoft Word, you can probably purchase separately, but, you know, if you were to purchase Microsoft Word, Excel, Access, PowerPoint, all individually, it may cost you more, right? But if you purchase them together, you can get the bundled version for a lesser price, right? And also, if you do that, the advantage is what? If from the same vendor, they can work together versus buying a spreadsheet software from a different company versus word processing from Microsoft, right? In that case, you cannot expect them to work together. But if you purchase everything from the same company, then you can maybe embed an Excel spreadsheet into a Word document, right? And the main advantage is what? Cost effectiveness. A lot of examples of softwares, from each of the vendors, right? Take a look. And other type of popular softwares that we use, in addition to personal productivity is TurboTax. This is a tax season, right? April 15th around the corner. So a lot of people are using TurboTax, either a PC version or online version, right? All kinds of educational software too, like the one that we're using, Canvas and Zoom, right? And if you're into gaming and other things, then you can use other type of software for developing games, computer-aided design, mechanical, electronics, civil engineers, right? They use this type of software for creating design, right? Statistical software like MATLAB and what can I say, SPSS. We're into too much of mathematics and statistics. So any kind of general world, function, there is a software because there is a market. You will have companies develop software so that they can make money, right? And as far as mobile application, you have softwares in the what? Millions, because individuals are developing those software, right? They're saying on the iPhones or in Apple Store, right? You have about 2+ million applications. Same thing with Android, because not always companies producing it, even individuals can do it. That's where, as I said, if you're interested in mobile application development, there's a lot of potential, right? To make money, where you can develop a software, upload it to the App Store, and then you can charge a fee, right? Folks to use that software. And look at the categories of mobile application: books, entertainment, finance, gaming, lifestyle, music, right? Think about any field, I'm sure you'll find a whole bunch of apps, out there, right? And if you look at this slide, you can think about all the apps that you have installed on your own phone and then try to link to which category, right? Those belong to. And Workgroup, obviously, softwares that allow 2 or more people to work together. For example, SharePoint, right? Multiple people can collaborate on a document and then, make changes same time. It never used to be possible, maybe 30 years back, right? But now we can. Because a lot of the teams are what? Spread across different locations, right? That's where some of these softwares came into being. As far as enterprise is concerned, what can I say? These are softwares that are built what? To handle the operations of the entire company. Accounting, finance, sales, HR functions, everything managed using a single software developed by the same company, right? Allowing the managers and workers to stay connected because all from the same company, right? It's very cost effective, makes the installation easy, runs on similar type of hardware and operating system, right? Overall, the cost of running these softwares is a lot less expensive than if you were to buy, softwares from individual vendors, right? And also these enterprise software vendors are developing versions of these softwares for what? Smartphones, because most of the people today have phones. They want to have access to their application and data from their phones, right? Let's see. As far as programming languages, that's what these softwares are built, right? On. What are the different types of programming languages you are familiar with? Anybody? .NET, right? C#, Java,
C, C++,
C, C++,
SQL.
SQL, that's right. Somebody said Python, right?
Yeah.
Hundreds of languages out there, HTML, CSS, everything is a language, right? Every language has a set of keywords, commands, rules, right? For constructing the statements. That's how we are able to communicate, right? Instructions to the computer. And as people in IT field, you need to know, a lot of programming language. That's how you will increase your value, right? So if you're already familiar with these, that's great. If not, this is the best time to learn, right? As far as Apple is concerned, they have their own, programming language like Objective-C and Swift, right? Starting with COBOL back in the 1960s, very popular financial companies, very popular for, those types. Then came C, C++, Java, JavaScript, a language that was almost considered dead, just came back. Nowadays, everybody is using JavaScript. We had Python, Ruby used to be popular. I don't know about, now. SQL, what's the expansion of SQL? Structured query language. That's how you communicate with the database, right? Retrieve data, save data, all kinds of things we can do. Billions of lines of COBOL code, right? It used to be the way 10 years back. I don't know if still companies run applications on COBOL, but still might be. And as far as software is concerned, what are the other things that you need to be aware of, issues-wise, trends, right? When it comes with software, you can always expect every software to have some kind of a bug, right? Without bugs, there's no software, right? So you need to have a plan in place to manage those bugs. That's the point here. And other things with software, copyright licensing. Just because we have a software that we can download, and again, think about it as a manager of a company, you should always concerned with what are the licensing considerations, right, for using that popular software. Open source wise, obviously, if it's open source, then there's no licensing issue. But again, you need to be concerned about support, right? There's a problem, who do I go to, for fixing that issue? There may not be an individual, but you can always look up for forums and communities, right, for help. With software, there are always issues with bugs and upgrades, right? And as a manager, as a department, you need to plan for that, be it operating system, be it application software, right? A lot of the companies offer what's called global software support, 24/7 support. So if you're purchasing a software, that's something that it's essential for your company, you need to make sure that there is always this 24/7 support, right? Bug-wise, these are things that are introduced in the program as part of the programming that'll affect the functioning of the program, right? So some of the things you can do to avoid some of the impacts of these bugs. Register a lot of the software so that you can get some updates regarding any of the bugs. Before you install a file, make sure you read that README file, right? That tells you some of the existing problems, right? Need to be aware of. And make sure you install the latest software updates if you can. That may have fixed for some of the bugs, right? And one of the challenges with bugs is what? Being able to recreate it, right? Sometimes the user will call to report a bug, then they're not able to explain clearly how they can reproduce, right? Only if you're able to reproduce, you can get some assistance from the manufacturer, right? It's never a good thing to always go for the latest version, right, of a software, because that'll have a lot of bugs. May have new features, but you need to be prepared for some of the bugs. So it's always better choice to wait for, some time before installing. So all of the softwares usually are protected by copyright laws, you need to be aware of, right? That gives you limited, the use of the software, right? Sometimes you cannot modify the code unless it's an open source software, right? And most of the softwares today, if it's a commercial, you need to register and activate it before you can use the entire feature, right? And some cases you may have single user license, which is kind of the cheapest version. But if you're buying a software for entire department, then you need to buy bulk license, right? Which can be more expensive. We talked about open source. It's typically free and source code is available. You can enhance. Let's see. So as an IT department, right, especially the managers, they need to have a strategy for what? Upgrading the software. Something that you don't need to do on a monthly basis, but at least every year, once in 2 years, right? Or else your software may become go off support or may lack some of the latest features, a lot of bugs, right? So that's something you need to plan ahead of time. Is the point, right? Although some of the software upgrades may cost you money, but some of the features that are introduced may be of greater benefit to the company, right? Talked about global support. Some of the challenges with global support that IS teams may face is what? Some of the cultural, the language issues that you need to be aware of, right? Summary. That's pretty much on chapter on what? Hardware and software. Anybody, any questions? Okay. So a few things I want to mention. It's something I mentioned last week. Make sure you form your teams. I know I saw some emails from some of the leaders, right? And if you haven't found one, don't wait, right? And I think for your class, I mentioned that you need to name your teams from group A through maybe E, right? Group A, group B, group C, group E, group E. And this will help you do some of the group projects, right? What was the project for last week? Anybody? Was there a assignment for last week?
No.
Yeah, the assignment was to form the team, right?
Yeah.
So this week, since you've already formed the team, right? The assignment I want to give for your team. Do you want an assignment or not?
Yes.
Is pick a popular software, right? And that's what, as a team, you need to decide and write a 2-page, up to 2-page, right? You can call it a paper, whatever. Talks about what is the functionality of the software and who's the vendor, right? And things like what are the companies that are using that software, right? Whether there's a cloud-based version of that. Also, some of the main, things that you read up in forums about the popularity of the software, also the issues, right? So hopefully you got that, right? any software purpose, which should take at least half a page, right? Explain the features, functionality. Maybe you can include screenshots. And also, as I said, which companies are using it. So think about enterprise, don't think about personal, right? And some of the things you hear about that software also. Some of the major features, right, or issues. So that's your assignment for this week, and it's due Friday night, okay? So hopefully we have representatives from each team in this, in the class. And you're able to work with your team to complete that assignment, okay? So any other questions on whatever we covered today or anything, we've covered so far? Okay, so one last thing is, I know I mentioned this about the YouTube assignment. I don't know if any team signed up, right? If you're still thinking about it for that extra credit, this may be a good time to decide. If you're not interested, that's fine. But if you are, you need to let me know so that I can share the details, right? I'll just post an announcement with information, but if you're interested in that extra credit as a team, better to get started early on, right? Is what I've seen. The teams that have done well, they started early on. They didn't wait until the last week, okay? So if there are no further questions, I wish you a wonderful week, and we'll talk to you next Tuesday. Good night.
Good night, sir.
Good night, Professor.
Night.